Hello and welcome to another fun-filled day in math with Mr. Sims. Today we're going to be talking about triangle congruency. In other words, how do you know if two triangles are congruent? And there's basically a few that we're going to look at today, alright? There's side, 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 angle, side, hypotenuse, leg, angle, side, angle, and finally angle, angle, side. Now I know those are can be complicated, so we're going to take a look at each one quickly, and then we're going to do some problems, alright? So let's go ahead and start with the first one. So actually, let's do first of all just start with how do you remember all these? So one of the ways you can remember this is you start off with side, side, side. You can always, if you have side, 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 right? You can prove that the two triangles, if you know their sides are congruent, just like this side's congruent to that side's congruent to that side, that side's congruent to that side. If you know that, then you know that both of the triangles are congruent, alright? And basically the way it works is this. For all of these here, what you're proving with these different theorems here, or these different postulates, is that you can only make one triangle given the information that you have. In other words, if I have this side length, and this side length, and this side length, and they're all interconnected, right? The only triangle that I can form is this particular triangle. So if I have another one that happens to have those exact same side lengths forming a triangle, then I know without a doubt that that's the same triangle, that they're congruent, because you can only form one triangle given those sides, alright? Likewise with the side angle side, if I have a side here, and then I have an angle in between, and then another side, right? If I have two sides with the angle in between them, I know that, then that also means I can only form one triangle that fits that. And we can look at that a little bit later. But basically, I just want you to understand, basically what you're doing is you're just proving that you can only form one triangle by it, right? And by doing that, if you know those pieces are both triangles, then you know that they are congruent, okay? So anyway, so let's start with side, side, side. So basically, this is one of the ways. You need to remember these 5 ways here, okay? It's very important that you do. So the first one's side, side, side. The next one, I'm now going to add an A, but it's very important that the position of my A is in the middle. This position of your A cannot be in front, okay? This is not okay. And you can remember because it says a very naughty word, right? So don't choose this one. If you put the A in front, it's incorrect, okay? That angle that we know has to be in between the two sides. Now, likewise, if I choose to write it like this, that, by the way, is the same naughty word backwards, so it is also out, okay? So once you add one A, the only way that it works is to have SAS, the two sides knowing the angle in between those two sides, all right? So very important. This is one way that you can prove congruency. This is another way, all right? Then you can have the situation where you can add two A's. So this is add one A to the mix. So get rid of one S and you add one A to the mix, okay? So this one we're going to now add two A's to the mix, okay? We're adding two A's. And if we add two A's to it, two angles to it, then what we can get now is we can get angle, side angle, right? That's where the side is in between, right? We also have a valid angle, angle, side, right? And just so you know, we also have side, angle, angle, but really, that's this one. They're both the same thing, right? It's just a matter of how you look at it. Angle, angle, side, or side, angle, angle, right? It's just how you read it on the triangle, right? So this is actually the exact same thing. I'm going to just get rid of it. It's not necessary. So once again, if you add two A's, then both of these work. So I'm going to go ahead and box in this, right? Now, if you add a third A, right? If you add three A's so that all you have, right? If you add three A's so that all you have is, A, that does not prove congruency because that's basically a dilation. A dilation would have all the same angles, but all the sides would be proportional to one another. And so that right there, adding three A's does not work. I want to stress, does not work. So once again, the only ones that work with the side, 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 angle, side are basically side, 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 angle, side, angle, side, angle, 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 side. Stressing to you that this one, the naughty one, does not work. Does not work, okay? Now, there is one situation where the naughty one does work, and that's in a special scenario where you have a right triangle. If you have your right triangle, let's say, hypothetically speaking, that I knew I had this angle here, and I knew the hypotenuse, right? We would say that this is HA, okay? We would say it's HA. And what HA really is, though, if you look at it, what you have is you have the hypotenuse, which is a leg, right? Not a leg, a side, right? And you know two angles. So you have angle, angle, side. So angle, angle, side, which is this one right here. So HA is really just another way of saying angle, angle, side. Well, likewise, you could have, right? Let's say you didn't know that. Let's say you just, didn't want to do that. me try this. Ready? Erase some of these markings, right? Let's say now that I knew, let me actually get another layer so I don't mess that one up. So let's say I also, instead of that, let's say I knew my leg and my angle. Okay, let's say I knew one of these legs was congruent and the angle. Well, what that would be then if I had leg angle, right? That's basically the same thing as saying angle, side, angle, because I already know the 90 degrees are congruent, right? So that's really just angle, side, angle, which is this one here. Okay, so I have angle, angle, side, I have angle, side, angle, right? And I'm also going to have, just for the record, I'm also going to have the side, angle, side, and I'll show you what that is, right? Let's say I knew that this one here, right, and this one here were congruent, right? Well, what that is right there is that is actually, they call it leg, leg, right? But leg, leg is really just side, angle, side, because you know that they're both right angles, right? So side angles. The reason they call these leg, leg, by the way, is H is reserved for just the long hypotenuse, okay? So anyway, so these are all the ones that we don't mention over here. But the reason we don't mention them is because they're just redos of the other ones that you already know, okay? So there is one special case, though, that it does mention HL. And let me show you why it mentions HL. It mentions HL because HL, you have the hypotenuse, right? You know that they're congruent, and you know a leg is congruent. Well, as you know, if this is HL, right? If you think of it in terms of any triangle, really what you know is you know a side, and an angle. Or you know an angle, a side, and a side, which I told you is the naughty one. Naughty, naughty. And in any triangle, that is the naughty one. And it cannot prove congruence unless it is a right triangle. In a right triangle, it is equal to angle, side, side, right? But you got to remember that in a right triangle, it does not, if it's not a right triangle, it does not work. But it does work in a right triangle. So HL is a very specific scenario that only works in a right triangle. All right, so I hope I clarified that a little bit. So that's basically how triangle congruence works. So what I'm going to do is I'm just going to run through a bunch of problems so that you can see how they play out. All right, so here we go. Let's start with the first one. So it says, write a statement that indicates that triangles in each pair are congruent. So first of all, to start off with this one, you got to figure out how is this the same as this one. And remember, corresponding parts have to correspond. So this one here says triangle YWX is congruent to triangle TWR. So what this one's is saying is that triangle YWX, right, is congruent to triangle TWR. Well, let's think about this. If Y is the first one listed, then that has to correspond with the first one listed in the other one, which is T. And as you can see, those are not the same angles, right? They're not congruent to one another. So that could not be the way that that's listed out, right? So let's go to the next one. Triangle WXY is congruent to triangle TWR. Triangle WXY, so it's going this way, right, is congruent to triangle TWR. Well, as you can see, these two are congruent. So this one, if it starts with W, this one should also start with W, which means that that one is out. So B is out. So now we're going to look at C. C says angle XWY, right? So it's going this way, right? XWY is congruent to WRT. And you can already see that that's not right because X needs to correspond with the T here. So that is also incorrect. Let's go to D. This triangle WXY is congruent to triangle WTR. Well, let's see. Triangle WXY, right, is congruent to triangle W. These two are congruent to one another. T is congruent to the X, it says, right, which seems to match, and R. So they match. They match in the order. So W corresponds to W. The X corresponded with that T, and and Y corresponds with the R, right? And by the way, the WX line is congruent to the WT line as well, right? And likewise, the XY is congruent, right, to the TR, right? So yeah, this corresponds. It all works out. So the answer is D. I'll do the last one too. WXY should have corresponded with WTR, but instead they said R when R and W don't correspond. So that would be out, okay? And what I mean by don't correspond is R is the three-lined angle and W is the one-lined angle. So those need to be in the same order with one another, okay? So all right, here we go. So hopefully that made sense for that one. Let's go ahead and move on to the next one. So this one here, once again, it looks like I could actually accomplish this by just moving this, rotating it like that, right? Like a hinge right here, right? So basically, if I had x, y, w, I should have b, c, w, right? But let's go ahead and see what we have here. Triangle y, yxw should correspond with cbw then, right? And hey, look at that. It does. Hey, first one, isn't that nice when they give it to us right off the bat, right? I always like check my other answers though. YWX should correspond with CWB, but it's actually WBC, so that's not right, right? Triangle WXY should correspond with WBC, but it's not the case. Triangle XWY should correspond with triangle BWC, and it's BCW. These two need to be switched around, right? Need to be switched around. So that's out. And finally, triangle YXW corresponds with WBC. That's also not right. Okay. Why? No, because it should be start with C. So that one's out too. So the answer is A. All right. So 1 and 2 are in the books. Let's go ahead and move on to the next one. So what do I got here? Okay, number 3. Determine if two triangles are congruent. If they are, state how you know. Well, all right. Well, let's look. We know that two sides are congruent. We also know, or we know that those two sides are congruent, right? We also know because these share this side right here, right? Because it shares this side, I know that this side is congruent to itself, right? And because this angle is congruent to this angle here, right? I actually have a situation, which is kind of cool, where are these the same? Well, let me see. This one here, I have a side angle side. So for this triangle here, I have side angles, side angle side. And as we know, side angle side does work. This one here, though, we have also a side angle side, right? So if they are, state how you know. And the correct answer is yes. By side angle side, they are congruent. Side angle side, okay? So, does that make sense? All right, let's go on to the next one. So, and once again, you're just proving that there's only one triangle that you can make with those, right? Because if you have this side length, and you have this side length, and you have to have this angle in between them, there's only one segment, line segment that's going to fit there. So this triangle has to be congruent to this triangle, if that's the case, okay? Let's go to number 4. So this one here, what we have is we have a side, we have an angle, and then this side here is congruent to itself. So once again, you have a side, angle, side, and a side, angle, side. So this one really is side, angle, side again, okay? Side, angle, side, all right? Let's go ahead and do this one here. This one here, we know, okay, so we know this side is congruent to that side. We know this side is congruent to this side. So right now, I have a side. If I knew this angle, I could do side, angle, side, but I don't know that angle. So I have to see, is there any other piece of information I know? Well, if you look at this one, they share this side, right? So this is an example of side, 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 right? All right. So let's go ahead and look at this. I really wanted there to be an example of angle, side, angle, or angle, angle, side, but it didn't show up on this particular worksheet. All right, let me go ahead and do another one. So side, angle, side. If you're looking at side, angle, side here, right? Let's see, you have, they want to prove this, all right? See what additional information is required to prove that the triangles are congruent for the reason given. So they want it to be congruent by side, angle, side. So because they want it to be congruent by side, angle, side, we already know that this side is congruent to itself. So really the only side that we need to know at this point is that this side is congruent to this side. So we need to know that ZK, right, is congruent to LK, all right? If we know that ZK is congruent to LK, right, then we know that those are, and this should be a capital K, sorry, then we know that those two are congruent because we already had to have a side, then we'd have the angle, then we'd have our final side, okay? So we need ZK is congruent to LK. All right, let's go ahead and do hypotenuse angle. So hypotenuse angle, if you think about it, remember, hypotenuse angle, what you're doing really is angle, angle, side. So I need one of these angles to match one of these angles here, okay? So I do have my side, right, which is my hypotenuse, right? And I need an angle, just one of this. I either need to prove that angle I is congruent to angle D, or I need to prove that angle H is congruent to angle C. Either one of those would suffice, okay? So let's go ahead and see, if the answer choices are there, it'd be really easy for you, right? But basically, if you don't have the answer choices, basically you're just saying that angle H has to be congruent to angle C. And if I have that, I know there, or, because I could also have angle D, is congruent to angle I. All right? Sorry about the lean of that. Angle I. Okay? All right, hopefully this is making more sense to you than it did before. Let me continue on. Determine if the two triangles are congruent. If they are, state how you know. All right, so this one here, you have an angle, angle. So you could try and prove it by angle. But as we learned about earlier, can you know just by angle? The answer is no, because if I have two triangles, let's say I have this one here, right? And then I have a bigger one with the same exact angles, right? If I have this triangle here, where these are congruent angles, right? The triangles themselves, however, are not congruent because you can see the sizes are way different. Even though the angles are the same, this one's really a dilation of the other one. In fact, you can see it just getting blown up, right, to create this other one here, right? I hope that made sense, right? Right? It's kind of getting blown up to make that other triangle. You see what I'm saying? So anyway, so angle, unfortunately, does not prove congruency. So, are these triangles congruent? The answer is we don't know. We don't have enough information. Not enough info, yo. All right, we need more info. All right, give us a number 9. Woohoo! All right, so number 9, basically what it's saying is that this angle is congruent to that angle. We have that this angle is congruent to that angle, right? So, do we know that these are congruent based on that? Well, we have to realize that there's another piece of information that we have, and that is that this side is congruent to itself. So now I have angle, side, and angle, side. So angle, side. Does that prove congruency? And the answer is what? Angle, side does prove congruency, right? Because it's not the naughty one. No, angle, side. Anyway, moving on. So angle, side. We're good. All right. So once again, by angle, side, that one is true. Okay, let's go ahead and do number 10. Number 10 says that we're going to start with this one being a 90-degree angle. The reason I know that's a 90-degree angle is because these are a vertical pair, right? So that's congruent to that. All right, so now what I have is I have a side, angle, side. Side, angle, side. And as you know, side, angle, side works, right? Side, angle, side does work, but it's going to have a different name because it's a right triangle. So you want to look at what pieces you have, and really you ignore the right triangle. It assumes that you know there's a right angle because they're both right triangles. So for the right triangles, you would call this leg. So this is congruent by leg, also known as side, angle, side. Like I showed you over here, leg is equal to side, angle, side. All right, let's go ahead and move on to another one. State what information, if additional information is required in order to know the triangles are congruent. So if I want to know it by leg angle, remember, leg angle, basically, right? The leg cannot include the hypotenuse. That's h, right? So we need either this one to be congruent to, well, I know that this one here is a 90-degree angle, right? So I either need, well, I know that this is congruent to one to itself, actually. So leg angle, I really need just one more angle. It could either be this one or this one here. So the answer is, which one is it? And the answer is it could be either, right? So I could have this one, right, congruent to this one, right? So if angle L is congruent, right, to angle Y, that would work, right? Also, by the way, if angle M is congruent to angle M, that would also work, okay? So I just want you to see how that works. That either of those, if this one also were congruent, then I would also know. All right, that makes sense. So okay, so and once again, just so you know, leg angle. Really, what are you doing? Like, let's say I didn't know that one, right? Oh no, I'm sorry, I do want to know that one, right? Let's say I didn't know this angle though, right? Then really, what I have here is angle, side, right? Which works, right? I also have, if I didn't do that leg, let's say instead I did this leg here, right? Then what I really have is angle, side, angle, which also works, right? Angle, side, and angle, side, angle both work. And so that's why it works. It's just called something different when you have LA, okay? All right, let's go ahead and do another one. Find the measure of each angle indicated. So now what we're going to do is we're going to start working on some triangle, using some triangle theorems to figure out some sides here, okay? So we're going to start off with the exterior angle theorem. So the exterior angle theorem, you have your 3 inward triangles, and then you basically extend one of these sides out so that it goes past this angle here, and you know that this total amount here has to be 180, right? Well, what the triangle, what the exterior angle theorem says is that this amount here is equal to the sum of the other two angles in the triangle that's not adjacent to this exterior one, okay? So in other words, if this is 105, then that 105 is going to equal, right? Is going to equal 55, right? Plus, I'm going to call this x if you don't mind, because it just makes me happy. I'll call this x, okay? So 55 plus x. So 105 is equal to 55 plus x. So now at this point, I just subtract 55 from both sides. And I get that 50 is equal to x. So that tells me that this angle right here is 50. Bada bing, bada boom. All right? Let's go ahead and move on to another one. Once again, this is another exterior angle theorem, right? Where it says that this angle right here is equal to the sum of these two angles. So I have 146, right, is equal to 56 plus, I'm going to call that x again, just because it makes me happy. Because I don't like using question marks, all right? It's a neuroses. 56. And I have x is equal to 90. Woohoo! All right, so x is equal to 90. So this is a 90-degree angle, evidently. Pretty cool, huh? All right, so once again, hopefully this is making sense. This angle that's adjacent to that inward angle here, the exterior angle, is equal to the sum of the two other angles that's not adjacent to it, okay? Let's go ahead and do another one. Now this one here, they start making it evil just because they can, right? Let's face it, if you could make everything evil, you probably wouldn't because you're just too nice. But if you were a weirdo, you just might. So here we go. Let's see, you have 5x plus 5, right? Oh, sorry, let me do this. Once again, this is an exterior angle, right? And it's equal to the sum of these two. I put both of these together, and in so doing, I should equal this angle here, right? So I get 9x. So I get 9x plus 11 is equal to 50 plus 5x plus 5, okay? And at this point, it's just solving, right? Once you have it set up like that, it's really just a simple algebraic solving for x, right? So I'm going to start by subtracting 5x from both sides, right? Subtract 5x, right? When I do that, I get that 55. I'm going to add that 50 and the 5 together. So I get 55 is equal to 4x plus 11, right? Sorry, it keeps connecting my numbers. I don't know why it does that. It just makes me unhappy. So 4x plus 11. I should get, what's that, 44? So I get 44 is equal to 4x, right? Which, if you know your math facts, you already know that's 11, right? But I'm just going to go ahead and divide both sides by 4, solve it algebraically, and I get x is equal to 11. Yay! The crowd goes wild. Okay, here we go. Oh, boy. All right. We'll do one more, and then we'll do, actually, one last one after that. All right, so here we go. So 9x minus 3. Here we go. So once again, that 12x plus 6, right, has to be the sum total of these other two angles here, right? Oh, no, Mr. Sims, you almost made a mistake. This is not an exterior angle. If it was an exterior angle, it would be right here. Or it could be right here. But this is actually a vertical angle. In other words, this angle is congruent to this angle here. So this is 12x plus 6. Oh, that one almost got Mr. Sims. Oh, Mr. Sims. All right, so what I'm going to do is I'm going to get, I know now that I have all my interior angles. Well, as you know, the sum of all the interior angles of a triangle are all 180 when you add them all up, right? So I'm going to take my 9x minus 3. I'm going to add to it my 30. And I'm going to add to that my 12x plus 6. And I always like to add in parentheses just to start. And all of that is equal to 180. The reason I do that, by the way, is just if it's a minus sign, you have to distribute that minus sign, and I don't want to ever get me. So I just start off by getting good habits, okay? So now it's just a matter of, I can get rid of those parentheses. I now have 9x minus 3 plus 30 plus 12x plus 6 equals 180, right? You add these puppy dogs together, and you should get, what is that, 21? You get 21x minus 3 plus 30 plus 6 equals 180, right? Matter of just simplifying, combining some more like terms, right? I end up with 21x plus 33 is equal to 180, right? Subtract 33 from both sides, right? So I should get, what's that? 180 minus 33 is going to be, 47. 47 is equal to 21x. Why do I feel like this should have turned out nicer? Maybe it didn't. Hold on. What do they want me to solve for? Oh, this one they wanted us to find angle A, by the way, in case you're wondering. I'm sorry, I forgot to write those instructions. So 21x is equal to 47, right? So I'm going to divide by 21 and divide by 21, right? And I should get, is that right? No, it's not right, Mr. Sims. Mr. Sims, no, no, no. 147 is equal to 21x. There we go. So 21x is equal to 147. I'm going to go ahead and take, Alexa, what's 147 divided by 21? Alexa, what's 147 divided by 21?
147 divided by 21 is 7.
Okay, so it ends up being 7, okay? X is equal to 7. Now, 7 is not my answer, because they actually want us to find angle A. Sorry, I accidentally cut that off the screen. So that's going to go in here now to find angle A. So I have 9 times 7 minus 3. 9 times 7 is 63, minus 3 is 60, which is the correct answer. Feels good. All right. I hope this has helped you out. I hope this has helped you out quite a bit in figuring this out. Let me do the final last one here real quick. This one, it wants you to find what could be the possible third lengths. So just remember, whenever you have a triangle, right, two of the sides have to be bigger than the third side. So in other words, let's say I did have a third side. Well, these two have to be bigger than that third side. So if I add these two together, I get 16 plus 9, which is going to be 25. So the biggest that my thing could possibly be, it can't even be 25 because this has to be bigger than it. So x has to be less than 25. It can't equal 25 because if it did equal 25, I'd have a section of line that was 9, right? And I'd have another section of 9 that was 16, right? And if this amount here was exactly 25, it would just be a straight line. It wouldn't buckle at all at this point here. It wouldn't buckle at all. So in order to have it buckle, it has to be less than 25. 24 would be too short, though, because it could be 24.95, right? And it would still buckle ever so slightly here in between the 9 and the 16 segment, okay? So 25 is the biggest that it can be. So the question is then, what's the smallest that it can be? Let's assume for a second that 16 is the biggest side. So if 16 is my biggest side, right, then 9 goes from here to here, let's say, okay? Let's say that this amount is 9, okay? So this amount here has to be bigger than, when I add it to 9, has to be enough. Alexa, stop. So when I add this amount to it, whatever this x is, when I add it to the 9, it has to be bigger than 16 to actually cause it to buckle, right? To buckle at this point, right? So this x here has to be big. This x plus the 9 has to be bigger than 16. So you ask yourself, well, what would make it 16 right on the dot? And the answer is 7, right? If I add 9 plus 7, I get 16. So 7 has to be less than x, okay? So once again, what I did was basically I added those together to see what would the biggest number have to be, right? Or I assumed that this bigger one was the biggest number, and I figured out, well, what would have to be on the low end, what would have to be bigger than, okay? So 7 is less than x is less than 25. All right. Okay, I hope that has helped. We talked about triangle congruency. We talked about some of the exterior angle measurement and the and also the interior, some of the interior angles, right? And so I think I'm feeling pretty good about this. The only other thing I'm going to explain really quickly is angle side angle and angle angle side. I've had a couple of students be really confused about those, so I'm going to explain it right now. If you have angle side angle, yes, you do have similar pieces, right? Let's say I have this triangle here, right? And I have this triangle here. And I wanted to prove that they're congruent. Well, if I wanted to prove they're congruent, if I had two angles, right? Let's say I had this angle here, and this angle here, and this angle here, and this angle here. All right, if I had those two and I had a side, my side can be in two different places, right? My side can be outside of those two angles, right? Let's say that this is the scenario here. If this is the scenario where my side is outside of those two triangles, in other words, here's a triangle, this leg is not in between those two triangles. So this is angle, angle, side, okay? This would be angle, angle, side. Because once again, that side is outside, whoops, it's outside of the angles. I wish I could write that a little bit better, just so you can see. Let me zoom in, maybe I could do it. Outside of the angles. All right? You'll notice if it looks like this, let me make two triangles again, right? Okay. Whoop. Oh, don't want to do that. All right. So let's say I knew these, and I know those don't look congruent, right? But we don't base it on the looks. We base it on what we actually know, right? Mathematically speaking. So once again, I have two angles, right? In fact, I'm going to draw my two angles in different places. Notice they're still the same angles, right? In this case here, let's say I know that those two sides are congruent again, right? Well, then what I have here is angle, side, angle. The reason I have angle, side, angle is this side is between the two angles, right? Just like it is with the anagram, I guess. Yeah. Is that right? Yeah. I forget. So anyway, does that make sense? So that's the big difference between angle, angle, side, and angle, side, angle. All right, well, I hope that that has helped. Once again, we just to quickly review, we talked about what are the different ways to prove congruency, right? We talked about if you have a right triangle, how those get renamed different things, but they're the same exact thing, right? The only one that's a special case is this hypotenuse length because it corresponds to the angle side side or the side side angle, which is a no-no because it's a naughty one, right? We also have that angle, angle, angle doesn't work, right? And then we talked about, you know, how the pieces actually have to correspond when you're labeling them, that they have to be in the same order, right? That the line segments have to be in the same order and everything. We also talked about like how you would figure out the pieces, right? I really wish one of these had been an angle, angle, side example. Sorry, I overlooked that. This one here, once again, we talked about pieces that you might need, right? Watch out for that where they share the same side, right? That can be a tricky one. And then we talked about how all angles cannot prove congruency. It can prove similar triangles, but not congruency. And anyway, I hope that that helped. It looks like you pretty much understood, hopefully, most of that. Once again, you can watch that again and work through the problems yourself, right? You can pause the video before I start working through it and just see if you got it, right? Anyway, I hope you have a wonderful, wonderful, wonderful time, and I hope that this stuff helped. Anyway, I do commend you for doing it, and I wish you the very best on any upcoming tests you may have. Have a great one.